Okay, so here's what the law says. The total momentum in the system, right? The total momentum in the system the total momentum in the system remains the same if no external force forces act on the system. Okay. Okay, and I was making, I don't know if it was with this class or not, but I thought we start writing the law of conservation of momentum. Okay, it's almost like, okay, you have a daughter and you have a mother. If the mother, right, you have a mother trying to discipline her daughter, right? It always works. There's never any problem. Daughter will always obey, listen to what mom say, no problem. Okay? The system here is mom and daughter. Okay? It's always two things. Mom and daughter. They will get along fine. Mom say, okay, when I come home, I want that room to be ready, to be clean. When you wake up in the morning, do your bed. There's no problem. She will always do it. Help me with the dishes. Never a problem. It's always like that. But from the moment there's an external force, in this case, let's say dad get involved, then we have a problem. Mom say, by the time I get home, please do this. Dad will say, give her a break. She got homework to do. That's an external force. Guess what? The daughter gonna start listening to the dad and start rebelling. It's a natural phenomenon. It's just the way it is. Now she think, okay, all right, I don't have to do it because my dad got my back. And that's almost similar to that, okay? The total momentum in the system remains the same. Mom and daughter, they have a good agreement. There's never any argument between the two of them. They have a good harmony. Unless a third person comes and get involved. Yes, Manny, see you later. Make sense, guys? As long as only two people, there's no problem. From the moment a third person comes in, that's it. It messes up everything, okay? So just think about it like that. A system is always two things. Mom and daughter. External is the third person. He comes, he messes up everything. Okay? So that's the best way to say it. Okay? Collision. We have two types. Two types of collision. We have elastic and inelastic. Elastic and inelastic. Okay? So elastic collision is a collision in which, okay, make sure you take good note, hopefully you can see. A collision in which objects collide and bounce apart. I think that's what we say. And bounce apart. They collide and they bounce apart with no loss of energy. With no loss of energy. I believe that's what we said, right? A collision in which objects collide and bounce apart with no loss of energy. Okay. Collision, collide. Elastic, bounce apart. They don't stick together, right? They don't stick together. Then we wrote an equation, right? It takes two things to collide, right? So the first one, let's say, is mass 1 going at a velocity 1 initial plus mass 2 going at velocity 2 initial. After the collision, they're separate, so we get equal. Remember, the mass never change. We say that mass always stay the same. Mass 1, but the velocity changes. Velocity 1 final. Mass 1 times velocity 1 final plus mass 2 times velocity 2 final. This is the equation that goes with elastic collision. Okay? See, they're separate. They bounce apart. They're separate from each other. Okay? I is for initial. F is for final. Okay? So initial velocity, final velocity. Okay? So mass 1, V1 initial plus mass 2, V2 initial equal mass 1, V1 initial plus mass 2, V2. Sorry, mass 1, V1 final plus mass 2, V2 final. Okay? That's for elastic. Elastic, see, they're separate. They come, they bump into each other. After the collision, they're still separate, see? But the velocity changes. Right? And we say if the truck hit the car in front, and if the truck was going at 50, after the collision, what's probably going to happen is the truck will be going slower. The car that was in front will start going faster after the collision. Okay? So faster away from the other one. Okay? All right. That was number 1. Number 2, we have inelastic collision. Inelastic collision. Okay. Yes, Irina is here now. Good morning, Irina. Welcome. We're just going over where we stopped last time. We're just going over it quickly. Okay. So inelastic collision. It will be a collision in which objects collide. A collision in which objects collide and some mechanical energy is transformed, and some Mechanical. Mechanical, I believe it's CH. Mechanical energy is transformed, okay, it's transformed into heat energy. Into heat energy. Okay, heat is an energy too. Okay, it's an energy. Okay, Irina, welcome back. Okay, so inelastic collision is a collision in which objects collide and some mechanical energy is transformed into heat energy. Okay, it's inelastic. Inelastic means after the collision, they stay together. Right? After the collision, they stay together. Okay, bounce if it's elastic, stick together if it's inelastic. So this one is inelastic. Okay, so in inelastic collision, they move together after the collision. Okay? So here we are. Mass 1 times V initial 1, right, as the first core, plus mass 2 times V initial 2. After the collision, the two cores stay together. So look, I'm going to open up a parenthesis and have the two cores together. Mass 1 plus mass 2. They stay together times 1 velocity. Okay, now they stay together. They're moving with the same velocity. Okay, that's inelastic. Okay, so they stay together. So we put them in parentheses. And they move together as one. Okay? We will have this on the test on Friday. Okay? What this means is core 1 and core 2 collide, and instead of bouncing, it's not bouncing because it is not it's not elastic. It is inelastic, right? So there's no bouncing. So they're moving together. So yes, they have a shared final velocity. They're moving together. It's almost like the truck come hit the car and just push it, push it, push it, push it. So they're moving together, right? So yes, they have one final shared velocity. Okay. Vince, of course, you're going to have both, right? You're going to have definition and you're going to have actual problem. Okay. You'll have both on the test. Example. Okay. Example 1. Let's see one example with let's see if it's elastic or inelastic. Okay. So Toby and Chubby. Toby and Chubby. What question can be asked? What is missing here? What information is missing? No, that could not be the question. How do you hit a parked car? Yeah, that's a question, but that's not going to be the question to solve. After the collision, okay? After the collision, what question can they ask us? What is missing from the problem? Or what happened after the collision? What happened after the collision? What happened? Thank you, Jackie. You see, how far did you end up going? Exactly. That is what's missing. If Jackie's car was just parked and they come and collide with her car, of course, her car is no longer going to be parked still. It's going to be moving. So we need to find the speed at which Jackie's car is dragged across the floor or the road. Okay? So how fast is Jackie's car bumped across the floor? Bumped across the floor or the road. Okay? Dragged, yes, dragged or bumped. Okay? But right now, since it's an amusement park, it's not the road, right? It's that little space that they have, right? So it's like a floor. So dragged across or bumped across, okay? All right, everybody copy? We're going to try to write the given, and then we're going to try to solve it, okay? Can somebody help out? What is Jackie's initial velocity? Okay, 0 meter per second, right? 0 meter per second. Thank you, Jackie. Right? Because she was not driving. Thank you, Haley. She was not driving. She was just sitting down, right? The car is parked. So initial velocity for Jackie is 0 meter per second. Initial velocity for the twin is 15 meter per second. The twins' combined mass, 200. What are we missing? Jackie's mass. Mass of Jackie, 30 kilograms. Okay. And we know the twins' final velocity. So velocity twins final is 5 meter per second. Okay. And they're asking us to find Jackie's final velocity. There we go. Okay. So it's elastic. Okay. For elastic, we know the equation. Okay. All right. So take a look at your equation quickly. The long equation for elastic. Okay. Take a look at it. MT, MJ, V initial, V final, 5 meter per second, initial, we want to find V final, V Jackie's final. That's the one we're looking for. Jackie's mass of Jackie, 30 kilograms. Trying to make some space on the board. Okay, everybody take a look at the equation, right? The equation that you wrote for elastic, right? What did it say? Mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial equal mass 1 times velocity 1 final plus mass 2 times velocity 2 final. Okay? That's what it said. There goes early. Welcome, Erlen. Mark Yo, present. Jane is here. Good morning, good morning. Okay. Okay, that's what we have, right? So now let's think again. Let's think a little bit about this problem. What will mass 1 be? Can somebody guess what will mass 1 be? Haley, are you sure it's 200, my friend? Thank you, Frank. You guys, wrote that down. Mass of twins plus core. Frank, you always nail it. Okay, so what will the mass of the twins plus the mass of the core be? What would that be? 300, Sophia. Thank you. You see? Because they're together with the core. Okay, so mass 1 is 300 kilograms. What is the velocity of that core with the twins? What is that initial velocity? No problem, really. What would that velocity be? Help me out. What is V1 initial? Okay, guys, come on, let's focus on the problem. What will V1 initial be? Thank you, Sophia. 15 meters per second. Okay, plus mass 2. Now, what is mass 2? Be careful now. Thank you, Maria. What is mass 2? Okay, let's think carefully. What will mass 2 be? Sophie, are you sure it's 300? Is Jackie just standing by the road? Vince, are you sure it's 100? Thank you. Jackie is sitting in the car, so don't forget about the car, guys. Okay? The mass of Jackie and the car together, 130. Thank you. Okay? So 130 kilograms. Her velocity initial is 0. That's what we say. Right? Equal 300 mass 1 times velocity 1 final. Velocity 1 final. What is velocity 1 final? What's velocity 1 final? What's the velocity of the twins now after the collision? What is the final velocity? Five meters per second. Thank you, guys. 5 meters per second. Good job. 5 meters per second. Plus mass 2, which is 130. Times V final, V Jackie final. We don't know that one. That's the one we're looking for. Jackie's final velocity. You see? You see how this thing works? You guys are becoming smarter and smarter every day. You see? So mass 1 times V1 initial plus mass 2 times V2 initial equal mass 1 times V1 final plus mass 2 times V2 final. Good. That means you are alive, Vince. If your brain is on fire, that means the blood is flowing. You are alive. Haley, assume that was money in your bank account. Once you be happy, you'll be like, oh, give me more numbers. All right, take your calculator. Let's do this. Everyone, 300 times 15. Find out for me quick. Calculators, everybody. Natalie, everybody. Sitting on. Everybody, quick. I want unit. Give me some unit, guys. Kilogram meter per second. Okay, kilogram meter per second. Don't forget. Okay. What about this one? What is this one equal to? Zero. Thank you, Sophia. 0. And the next one. This one. We're trying to simplify so it's not a whole bunch of numbers anymore. Come on, guys, take your calculator. Boom, participate. Thank you, Sophia. Thanks, Brent. 1,500 kilogram meter per second plus 130 V Jackie final. Okay? How do we solve for this? What do we do next? So we got 4,500 kilogram meter per second equal 1,500 kilogram meter per second plus 130 V final. What do we do now? Add to both sides and divide. So what are we adding? What are we adding to both sides? We're taking Vince, we cannot add 1,500 and 130. We cannot do that. Subtract 1,500 from both sides. Haley, you cannot add 1,500 and 130 because look, Haley, this is 130 V final. There's no V final here. This is kilogram meter per second. This is V final. We're going to add them if they have the same unit. They don't. Okay? So kilogram meter per second, kilogram meter per second. We combine these two because they are the same unit. Okay? So we subtract 1,500 from both sides. Okay? So here's what we have. 4,500 equal 1,500 plus 130 V Jackie final. You learn all this in Algebra 1. Algebra 1 will be like 4,500 equal 1,500 plus 130x. So this is like x. We subtract 1,500, like you say, from both sides. Okay, so 4,500 minus 1,500, what will that be? $3,000. Okay, 3,000 equal 130 final velocity of Jackie. Now what do we do? What do we do now?
Divide.
Divide. Thank you. Divide by 130. Divide both sides by 130. Okay, so take your calculator, divide, and tell me what we get. So velocity final of Jackie will be about 23. Okay, about 23 meter per second. Okay, approximately 23 meter per second. 0.08, 0.07. Okay, go ahead, write it. Okay, so approximately this. Okay.